First and foremost, thank you everyone for joining us and taking some time out of your afternoon to view our webinar, Scaling Entity Framework Apps with this Distributed Cache. This has been a popular topic in the past, so we thought we would revisit it. My name is Adam. I am a certified Scrum product owner, and I'm one of the regional directors here of service delivery. So in layman's terms, I work with the end customer as they implement our scalability products into their environment, and the liaison between the end customer and our internal engineering team. My associate Ron, he is our lead enterprise architect. He's got well over a decade building enterprise applications, and he works extensively with our end customers on configuration sessions, technical talks, and webinars like this. He's also involved in the product strategy as he gets a lot of feedback while working with the customers. If you have a high transaction application in your environment, there's a good chance that you are using Entity Framework. If you are indeed using Entity Framework, there's also a good possibility that you could run into some scalability issues. So we're hoping this talk might give you some ideas for a few solutions. During the presentation, do not hesitate. You'll see there's a little questions form or tab on your GoToWebinar menu. Ask away, ask as many questions as you want. That's what we're here for, to get you all the information that you need. So with that being said, we're going to pass it over to Ron, and he's going to take it away from here.
Very good. Thank you, Adam. Hi, everyone. My name is Ron, and I'm going to be your presenter for today's webinar. So let's get started with this. The topic that we've chosen today is how to scale entity framework applications with the help of a distributed caching system. So I'll be using NCache. At Alachisoft, we have many other products, but NCache is the most popular one. It's our main .NET based distributed caching system. We'll be using this as an example product for all the discussion that we'll have in regards to entity framework scalability bottlenecks and solution. NCache as a solution to those bottlenecks. So this is what I have in agenda today. I'll be covering all the details, and let me know if there are any questions. For those of you who would like to understand how entity framework works, I'm just going to share some introductory details. Some slides are based on entity framework. I'm pretty sure everybody knows what entity framework is, but just for the sake of completeness, I'm going to go over these slides. Entity framework is a very popular object relational mapping for your .NET applications. It maps your conceptual object model to your relational databases. When you work with databases, you have tables. You have those tables related to one another, so there are relationships. So there's a proper schema on the database end. But when you actually start using that database inside your applications, you end up dealing with objects. Typically, it's your domain objects. So you need to have some kind of mapping between your domain objects and your data model. And that mapping needs programming, right? So you have to get ADO.NET object, you get a data set, data reader, data table, which is raw ADO.NET data structure, which is brought, which actually helps you bring all the records from the databases. But when you bring it inside your applications, it's not very flexible to use the ADO.NET objects. You actually would map those records onto your domain objects, your classes, your objects within your entities within your application. And on this side of the programming, you have the classes that you deal with. So one option is that you actually build your mapping yourself. The other option is that you use an OR mapper tool like Entity Framework, which works at the conceptual object level inside your application. It gets you data records from the database through ADO.NET, and then it provides a mapping and cuts down your development time. So you don't have to reinvent the wheel. You don't have to rewrite the code. It's something that would be done automatically with the help of Entity Framework. And this is why it's very popular, because it's very flexible. It could be database first or code first. If you have a database schema, you could just generate classes and mapping for that. If you already have the classes, you could actually generate the database and vice versa. Entity Framework is very popular, specifically for high transactional applications. When you have a lot of request load and you have database involved at the backend, so this is a very good choice to get started. On the functional side of things, Entity Framework uses .edmx file. which in turn contains conceptual models, CSDL, that contains entities and relationships between different entities. Then SSDL is your schema definition, whatever you have in the database, and then there's a mapping file between CSDL and SSDL file. So that's what actually maps your conceptual application model onto your database. And then we have object services layer, the objects that you actually use inside your application. You have an object context, a DB context. This is the primary class for Entity Framework. And then you query everything using typical SQL or link queries on top of your applications. And I can actually show you, I will be using a sample application which I have formulated just for this, and this is my EDMX file. I'll just show you the diagram that I'm planning to use. So we have customer, we have an order table, and then we have order details, and then we have an intermediary object as well, product supplier detail. I'll talk about it. And this application uses Entity Framework. As you could see, we have this context right here, and then we're making all the queries. For example, inside the Entity Framework application, we're using link queries to get data, and then we're saving changes as needed based on our requirements. And I'll show you how to introduce caching inside this application once we progress into the presentation. Again, some more details on Entity Framework. Entity Framework, again, conceptual model, storage model, and then we have mapping. This constitutes your .edmx file. On your application layer, you would always be dealing with objects, and that's the preferred approach. From there, you would issue a command through object services, through context, which actually goes to entity client data provider, and typically it's ADA.NET. And that's where you would execute the commands on the database, and then database would fetch, you would fetch some records, update changes, and that would get you ADA.NET objects back, and which again gets transformed into your objects, into entities on your object services layer. So it's a to and fro mechanism, but on your application layer, you would always be dealing with objects. And on the database layer, you would always be dealing with ADA.NET, and you don't need to know about what's happening on the ADA.NET layer. You always deal with objects, and that's what is preferred. Now, I'll talk about the problems within Entity Framework applications. If there are any high transactional scenarios, if there are applications which are using a lot of application load, you need to have scalability. So let's define what scalability is. Scalability is an ability to load or handle a lot of request loads, a lot of requests at runtime. So you could have linear amount of requests and linearly increasing, and you don't want to decrease your application performance. So if your application has an ability where it can increase your application request load and keep on doing that, and it does not compromise on the performance. A typical example that I use here is that if you're able to get a task or you have 5 users and you have certain performance for individual requests for those 5 users, and obviously that's going to be super fast because that's not dealing with a lot of users. You should have the same kind of performance when you have a million users or 5 million users on your applications. So if you don't lose the performance for individual user and you end up handling those millions or thousands of millions of users, that ability is called scalability. And these are the applications, and typically Entity Framework applications, when it's dealing with databases, it could be your ASP.NET web app, which is making use of Entity Framework. It could be .NET Web Services, backend or front end. It could be Internet of Things, any server applications, or it could be any other .NET applications which are going through Entity Framework to your backend data sources. They may need scalability because your application request load can increase at any point in time. So where exactly is the problem? That's the main question that we will actually help address in today's webinar. Entity Framework application layer scales out nicely. If you have deployed it in an application form, a web form, or it could be a backend application form, you could have multiple servers and you could load your requests on all the servers with the help of a load balancer. You could put a load balancer in front of your applications and your end clients, and then you can route your request evenly to all the resources. So it's already pretty scalable. You can have as many servers as needed, and as your load grows, those additional servers that you've added would take care of all that load. The problem lies with data storage, because Entity Framework always talks to a backend data source. Typically, it's going to be SQL Server, a relational database, right? That's the main issue. That's the main source where all your requests are going to go, and that's not scalable. And this is a diagram which helps explain this in in detail. You have your application form,
I'm gonna,
which is going on.
can I interrupt you real quick? There's a
Yeah.
question about the last slide, Ron. They want to know, is there any limit to the number of client servers or cache servers, or is there a ratio between them that's recommended?
Okay, very good. Okay, so yeah, I can take this question. Uh, there are no limits of how many cache servers you can add, and that's something that I'll cover on this slide. And typically, a ratio between cache servers and your application, it's a 4-to-1 ratio. So if you have 4 application boxes, you could have one cache server, which is good enough. So 2 servers is the minimum that we recommend, and based on that, you could have a 1-to-4 ratio as far as cache servers to web servers are concerned. But I'll cover this in some more details once we come to this particular slide. All right. So coming back to our storage bottleneck, basically you have a single source on this layer, and all your application servers. This is provided by ASP.NET Form, right? So you could scale out nicely. You can add as many servers, web servers or app servers, with the help of ASP.NET or .NET protocol. You can route requests to all of these, and then you can in turn go back to this database. This is a single point of failure. It's not reliable, but most importantly, it's not very scalable because it's single server. It's good for storage. It does not scale out. When you need to add more and more request load, there would be time that when this server it gets exhausted on the resources. It would not allow you to add more servers. It can allow you to scale up your hardware, but there's a limit to that as well. So after a certain point, when your request load is increasing and in a linear manner, this would choke down. And that's the main problem that we're trying to address with the help of a distributed cache such as NCache. Typically, you would think of NoSQL databases as solution, right? That's a very good technology that you can utilize. And as a matter of fact, we also have a NoSQL database within our company. It's called NOSDB, so we also provide that. But that's not usually a solution to help eliminate relational database scalability problem. It can replace your relational database, and it can ask you to use NoSQL database only, but you would essentially replace your existing data sources. So that's not a solution in all the cases. You need to re-architecture your application and start using the NoSQL database. Alternatively, you can use a distributed cache like NCache, which is fast because it's in memory. It allows you to add as many servers as you need to, and as you add more servers, it becomes more and more scalable than database to start off if you have 2 servers, and then you can add additional servers on the fly. And nice thing about this is that you can use it in addition to a relational database. It can use with a it can be used with a database. So you use a distributed cache which does not replace your existing database. It actually gets used alongside your database, and that's the real value in it, that you don't have to re-architecture your database programming. You introduce caching on top of it to help achieve the scalability benefits that you get out of it.
Ron, I know one question that I hear from clients that are discussing NCache with us is, does the application talk directly with NCache, or in other words, does NCache restrict the application from talking to the database?
Okay, that's a very good question. Okay, so when we say you can use NCache with a relational database, in this particular example you would be introducing, and in this particular webinar I'll cover examples where we'll uh, introduce NCache APIs inside your application. So you keep using your database, your application is connected to the database, data exists in the database, that's your master copy. The most readily accessed data is brought into the cache, and that's again your application which is bringing data into NCache. So it does not restrict your applications to in order to connect to the database. They still are connected to the database, but alongside that, they're also using a distributed cache. So they're managing 2 sources, and we have some additional features on top of it where NCache can also connect to the database for those synchronization and data consistency with databases. So coming back to your question, yes, in your application, you would be connected to the database. NCache would not restrict your access to the database. In addition to database, NCache would be used alongside inside your applications. I hope that helps. Moving on, we have some deployment options that I'll quickly cover, and that would also explain how a distributed cache is more scalable in comparison to the database. So this is a distributed caching architecture. You have your application forms, web services, server apps using Entity Framework, and then you introduce a caching layer. And in this application, in this particular diagram, we're not showing any connection between your application and the database, but that's given. Your application is using the database, and now it's also using the distributed cache alongside that. And this is a dotted line for some of the features that you would additionally like to turn on for synchronization between these two sources. We have some database dependencies and data providers that you can implement on top of it. But your application can very well use the database, and it can have its own connection. Preferred platform for NCache is 64-bit. It runs on all Windows environments. You can add as many servers as you need to, and it's very reliable because everything is in memory. You can add as many servers as you need to, and we have replication features to help support data reliability.
Ron, another question I hear in regards to this slide are what kind of prerequisites are there for the hardware in the caching layer?
Okay, only prereq for NCache is .NET 4.0, right? So you only need .NET 4.0 at the minimum on your caching servers or later, and that's good enough. It runs on all Windows environments, and on the client side, you don't even have to have .NET 4.0. It could even be 3.5, 2.0, .NET 4.0, 4.5 or 4.6, and onwards. So that's the only prereq for NCache. All right. As you add number of servers, it scales out, and this nicely explains this. From 2 to 3 servers, you can see 32 to 48,000 writes, and from 48 to 64,000 writes per second when you move from 2 to 4 servers. So you keep on adding more and more servers, and it actually scales out nicely in response to that, and gives you the linear scalability for your application. And this is exactly what you need when you're dealing with high transactional applications. And Entity Framework, in typical scenario, it will end up talking to the database, and that's where you see the real bottlenecks. Once you introduce a caching layer, it actually eliminates those bottlenecks because now it has a very fast resource sitting in between your application and the database, and you save your trips to the backend databases as much as possible. But you still use your database because that's your master copy.
Ron, I have two questions for you from the group. The first, I'll give you one at a time. The first is NCache compatible with a few different databases, or is there no dependency and it can connect to any database?
Yeah, it can connect to any database because it's based on ADO.NET provider, right? So, and we have our own API, which is .NET based. So there are two options you would use NCache caching. One is that you introduce NCache APIs inside your application. In that case, we would not actually interfere with even the ADO.NET layer. It's your application managing both sources. The other option is that you implement our ADO.NET provider. So it could be for any relational database.
Okay, question number two is, can data be written into the cache and write back to the database, or is the data spilled from the cache when written?
All right, so both options are supported, right? So basically, it could be, you can control within your application. I'll show you how this works. That you write data into the cache, and then you also update in the database. And similarly, when you need to fetch data from the database, you can actually add it in the cache. And then on top of it, if data changes in the database, you can remove data from the cache automatically. You can set up some database dependencies which can take care of that. Or you can use time-based expiration, so that if a data gets invalidated after some time, and then you know ahead of time that this data is valid only for a certain period of time, it would automatically be removed from the cache. So I hope that answers your question. Please let me know if there are more questions. All right, so let's talk about some common use cases of a distributed cache. Then we'll dive right into the examples, how to introduce entity framework caching with the help of distributed cache inside your entity framework application. So first use case for NCache is application data caching, and this is what we'll have in focus. We'll introduce NCache API calls inside your application, and you would use database through entity framework, and you use caching on top of your objects layer, services layer, with the help of NCache API. So you're managing two different sources, and we'll cover how to handle synchronization and data consistency side of the things. So in this case, you could cache almost anything. It could be entity framework, single objects, collections, data sets, anything that you get from entity framework, you can cache as a result, as a query caching. The entire collection can be one object, or it could be individual objects, or it could be related objects with those individual objects. Then we have some ASP.NET specific caching other than entity framework. You can use NCache for session state, view state, and output caching, and these are all no code change options. And third is NCache can also be used as a messaging platform. Any data which gets changed in the cache, you can get notified about it. And then your applications can send messages between one another. So that's an extended use case, but it's not something that I'll cover today. Today, I'll focus more on entity framework side of the things. All right, so let me give you some more details around NCache cache architecture so that we have some more details around how caching works, how it provides you scalability, high availability, and data reliability. And then we'll show you some code examples. Uh, NCache is highly available. These are some of the characteristics of NCache, distributed caching system. So it's highly available, it's linearly scalable, data replication and reliability is built into the protocol, and then there are some topologies such as client cache and WAN replication that you can additionally use on top of what you already have. All right, so it's a TCP/IP based cache cluster. It formulates a cache cluster. Logically, it's a single source, but physically, it's distributed on multiple caching servers in your environment. But you still connect to one source, and that's what you treat within your application with the name of that source, and underlying there could be multiple servers. And you can keep changing those servers. You can add more servers, you can remove existing servers, and this does not have any impact on the cache which is running or the clients which are connected to it. So dynamically, you can make changes to a running cache cluster, and this would not have any impact on your applications. Similarly, connection failover support is built into it. Any server going down would not have any application downtime or data loss. So everything is pretty dynamic. It gives you 100% uptime, a highly available cache scenario. Then we have many caching topologies. We have mirrored, which is an active passive. All clients only connect to active. That's where they read and write data from. And then active asynchronously backs up their data on the passive node. If this goes down, the passive becomes active and clients fail over automatically. Then we have active-active. Both servers have same data, but they have their own clients. And then there's a sync replication going on between caching servers. And then we have data partitioned, where some data exists on server 1, some data exists on server 2, and we get a logical view of the cache, but data is fully distributed. So all servers are fully utilized, and this is called partition cache. And then we have partitioning with replication. We have servers active partition and a backup partition. So one's backup on 2, server 2 is backup on 3, server 3 is backup on 1. So in a round robin fashion, alongside partitioning, we also have the backup partitions. And these become active if you lose a server. So if you lose a server, the backup becomes activated and you get all the data from the surviving node. So there's no data loss, no application downtime. And then we have same topology for WAN replication. You can transfer data for cache from one data center to another in an active passive and an active active manner. And then one last section that I'll cover here is you can also turn on client cache. For those of you who are coming from entity framework background, everything is stored within the application process, right? So that's extremely fast because everything is in process. But when you move your data out of your application, now that you have a distributed cache, it saves your performance in regards to database. Whatever is being fetched from the database, that's going to be super fast in comparison, right? So NCache would be super fast in that scenario. But for a scenario where your data is part of your application process, you would lose some performance because NCache would have serialization and inter-process communication overhead. So with client cache, you can create a local cache on the application boxes, which is in sync with the server cache. So some of the data can be made part of the client cache. If data gets changed in the client cache, it gets propagated in the server and vice versa. And this client cache can additionally be in process to your application. Any server going down, that would not have any impact to startup because data is available in the server cache. On top of it, you save on the serialization and inter-process communication overhead, because client cache keeps deserialized data. So it gives you the same kind of performance that you would expect, accessing data from within the application process. And we've just recently done a webinar on performance features of NCache, and this is one of the highlights within that webinar.
Just two quick thoughts. If the group has any more questions about the different architectures, please let me know in the questions box. I know we went through that pretty quickly for time's sake. And then also we have another webinar. It's on our website that we recorded on the different architectures. So it dives a lot deeper into the different topologies.
Very good. Okay. Next, I'll cover application data caching, and this is going to be used basically to introduce you towards our API. And this is what I'm going to base all my examples when we introduce entity framework caching with the help of NCache API. You get connected to the cache. This is the name of the cache. I'll show you how to create a cache in a bit. And then you store everything in a key value pair. Entity framework also helps you transform your ADO.NET objects, ADO.NET data into your domain objects collection. So you deal with classes, right? with API of NCache, you also deal with key value pair. Key is a string key that you construct yourself, and value is your .NET permitted object. Any type, it could be a domain object, collection, dataset. That's for regular scenarios, but for Entity Framework, it's since you already get the objects which are mapped, so you simply store those objects into the cache. So it could be your employee, customers, orders, order details, those sort of things. So you add data to it, retrieve it in a key value, update it, and then you remove it. And this is what we'll cover in deep details once we actually move on to that section. Next, I'll show you our environment. I'll show you how to quickly configure a distributed cache, quickly test it, and then start using it inside an Entity Framework application. For that, I'll bring you to our demo environment. I have demo 1 and demo 2. These are the two boxes which I have already installed NCache. All you need to do is go to our download page, find a fully working 60-day trial, 4.6 SP3 Enterprise Edition. That's what I'm using. I've already installed NCache on server 1 and on server 2. I'll create a cache between these two boxes. So to show you that there could be multiple boxes within a cache. And then I'll use my personal machine here to run an Entity Framework application. So let's see how it goes. I'll be using this management tool which comes installed with NCache. So you can use the manager right here. And this is what I'm using, but you can also use the command lines if that's a preferred approach. You can script everything from installation to configuration, as well as from monitoring standpoint. There are some things that you can configure through scripts. I'll go ahead and create a cache. Let's name my cache demo cache. All caches need to be named. You can come up with any cache name, and this is the name that you'll be using inside your application in order to connect to this cache. I'll keep everything default. Like Adam mentioned, that we already have an architectural webinar where we cover all these details in quite an extensive manner. So I'm just going to skim through these for this particular webinar, with an assumption that there are resources available on our website. Partition replica cache, choose next. Async, it's the most recommended one. And here I specify the initial servers which are going to host my cache. I have demo 1 and demo 2 where NCache is already installed. And these are going to be initial servers for my caching. TCP port for communication, size per server, and I'll just keep evictions to be turned off. I would like to keep everything in the cache, or you can turn it on. It's entirely up to you. These are the algorithms which control evictions. If your cache becomes full, only then evictions come into play, and they will remove some items to make cache up and running. And that's it. That has configured my cache. In the right pane, there are all the settings which are related to this cache. You can change any setting at any point, and then you can right click and choose apply configurations. And then I will add my box as a client where I've already installed NCache. And this will be used as a client node from where I'll run my application. And at this point, all my cache configurations are complete. I hope this was pretty straightforward. Next, I'll actually start and test this cache cluster so that it works fine and I'm able to use it inside my real application. So I'll just say start. Since all the configurations are complete, it would start the cache on 107 and 108, and then I'll be able to test it from 101, and I'll be able to connect to this cache without any issues. So I'll do that in a bit. So it's starting, and then I'll right click, verify that it's fully connected. That's very good. I'll right click and choose statistics so that we have some performance counters. No activity is being shown at this point. I'll just open a monitoring tool as well so that we can test it, make sure that everything is configured fine. So it looks good. I'll now come back to my machine and then run a stress testing tool application that comes installed with NCache, and it can simulate some dummy load on my cache cluster. And you will notice some activity generated on the server side. If I've spelled the name correct, yeah, I did. So you can see about 200 requests per second by server 1 and server 2, and then we have the monitor tool showing some activities as well. You could check this right here. Let me just run one more instance of the same tool.
Hey Ron, while you have a second, I have another question for you. The question is, why do we need to provide IP addresses of the server or / client to add to the manager?
All right, so in order for NCache uses TCP IP based cache clustering, right? So it needs an IP address and port to connect. The cache is formulated using TCP IP sockets, so it needs an IP address and a port. So I specified the IP. Machine name or IP is equally good. and then I specified a port so that that cluster can be started on that IPN port, so that communication can occur. Similarly, I specified the client so that client side configurations are mapped so that I have everything that I need inside the client configurations on that machine to connect to this cache. So this is why I specified the client IP from where I plan to run my applications, and those server IPs are the ones where my cache cluster is going to reside. All right, so I'm going to log on to this box right here and run another stress testing tool so that we have some more load, and you would see that the request load would increase. There are two clients now connected, and previously we were handling 200 to 300 requests per second. Now it's handling about 1000 to 1500 requests per second, and we have increased our load on the caching cluster, and you could see that. So everything looks good. I think we're good to go. Experiment this experiment with entity framework caching, how to introduce NCache API inside your entity framework application, and build an application on top of it. And I'll showcase two different ways. One is the API, the other is a no code change option, which I'll target towards the end of this webinar. The main focus today is to showcase the API side of the things, where you control everything, where you control the entity framework calls within your application. Whatever responses that you get, the objects, collections, or query responses, you can use that to cache inside NCache yourself. So you have full control on what you do on the caching.
Another question for you, Ron. So even if I provide the machine name, it translates into an IP address. If the IP address changes in the future, are you going to have to reconfigure the server again?
That's correct. That's with an expectation that your IP address would be static on your production environment, and that's the typical setting. But you can change the IP, and since we allow you to specify IP inside the service configuration file, let me just show you this real quick right here. So an IP address is actually specified here. So this is the IP address for NCache communication. Now if you change this IP, right, so in that case there is a tab within the manager. So I would recommend that you do this through here. Each time you change this IP, so you do it from the manager so that the updated settings are supplied on all the servers and the clients. Otherwise, if you change it without changing inside NCache, you would have to reconfigure your caches. I hope that helps. All right.
Yeah.
So
one more question about, and then another one to piggyback off that. If a machine has multiple IPs, can I provide any IP address while adding?
yes, the one that NCache is listening, that's the one that you need to specify. Let me just address this. If you have multiple IPs, you can use two different IPs for NCache communication, or just specify one for NCache communication. So there are server-to-server communication, so same IP can be specified for that. And there's a client-to-server communication, so same IP can be used for that as well. Multiple NICs, you have an ability to route NCache traffic between different NICs, so that's an additional feature that we have. You have to specify the IP that is specified within this configuration file, and we pick the one where machine name gets resolved. So that's the IP NCache uses by default, but you can change it at any given point, and that's the IP that you need to use inside NCache Manager and all the configurations that you make from that point onwards. I hope that helps. Now I'll come back to my presentation and then show you different options to start caching inside your entity framework application. So first thing that you might want to check is what sort of data to be cached. Let me just all right, there you go. Okay, so it could be your reference data, which is mostly a lookup kind of data, which is not changing very frequently. So you need to pick and choose what data you need to cache. You don't want to cache everything and bring everything from the database to the cache, because that's not something which is very optimal, because it's going to store everything in memory. So you would use the data in the cache, store it into the cache, only that's most frequently used, right? So that's mostly the guideline for caching, where you cache most of your reference data in the cache. But there could be transactional data as well, which is changing very frequently. It's changing as frequently as in 1 second, 1 to 2 seconds, 5 seconds, few minutes, or once every few hours maybe, right? But it is changing, and the frequency of the change is more than the reference data. Now, we also recommend caching some of your transactional data as well, because if you have a lot of users and your data is changing very frequently and if you not cached it, you would end up going to the databases, and think on the amount of requests that would end up to the database, and you would fall back to the same problem of scalability where you're not able to handle that request load. So we recommend caching some of your transactional data as well, and set up some kind of expiration on that data, so that while that data is valid in the database, it stays in the cache and you use it. And as soon as that expiration gets elapsed, that time gets consumed, that data would automatically be dropped from the cache. So we recommend caching some or all of your transactional data as well, to keep everything up to date. Then you can keep data fresh with the database. In that case, NCache can have database dependencies. Any changes in the database would automatically remove items from the cache. And similarly, you can handle relationships with the help of tags alongside entity framework queries. Once you make a query to the database, you can also run SQL and link directly on the cache as well. So from your application standpoint, it's not a big transition. You just need to introduce NCache APIs inside your applications. All right, a few requirements for entity framework, and then I'll show you some examples to get started with this. First of all, when you plan on using entity framework, uh, your entities do not move from one process to another. It's the ADO.NET provider on the entity framework which interacts with the database, stores data in the database, gets the data from the database, and then maps it onto the entities. So entities are not really moving from one process to another. But when you would introduce a caching product such as NCache, in that case, your entities may have to move from one uh, process to another, and that's your application process to NCache process. So in that case, you need to make sure that your attributes are your types are serializable, and this is very simple. You can make these types serializable by going inside your Northwind context file or entities, where you have all the entities. And let me just bring it right here. And then inside your entities, for example, we have the category class, right? All you need to do is make sure that this is marked with serializable. Let me actually, I'm looking at the wrong, yeah, there you go. So you need to make sure that all your attributes are, all your classes are decorated with serializable. So this is an additional step that you need inside Entity Framework, and that's the life of it. You don't need to change anything other than this. You just need to make use of API calls, and that's again on the application layer. So within Entity Framework, you need your objects to be serializable, and I've explained why. I hope that helps. And then you can turn off proxy creation so that lazy loading POCO dynamic types are not created, because that would again end you up in a deserialization problem. We don't know the types of those objects, so deserialization may be a problem. But that's not the case all the times. You may find one or two dynamic types causing this issue. And then in some cases, for those query results for which you don't know the types, you can cache them as is, or you could just transform them into a data transfer object, a DTO. And here's the example of DTO. For example, let me just show you from the, yeah. For example, we ran a query, and that query had a join in it from product and supplier tables, and it gets you some objects, some records. Type of those records is not determined, so that's a data transfer object that you need, and you can just construct the attributes based on your query. So I've just constructed product supplier DTO, and that's just for the sake of convenience, and I wanted to elaborate on the example more. All right, so let's quickly dive into the scenarios. So once you plan yeah.
One quick question, Ron, just as far as the serializable part. I've heard a lot of clients ask, well, what if I have hundreds or even thousands of objects that need to be serialized?
Okay, very good. So if you have a lot of objects that need to be serialized, right? So you would end up, one option is that you decorate them with serializable one by one, and I kind of agree that it may be a tedious task that you have to go through all the types. So with NCache, we provide a solution where you can serialize these automatically, and you don't need to make any code changes inside your applications. So you can come here, add types, provide your implementation where you select your classes, right? So bigger object, big object, normal object, these are my classes. Choose add class and choose OK. That's it. So these are the ones which you would simply serialize automatically, and you don't need to make any code changes inside your application as far as serialization is concerned. This is option number one. The second option could be to use our provider. In our provider, we plug in ourselves on ADO.NET layer, so you don't even need to serialize your objects or make any API calls inside your applications. So that's another alternative to this. But I would actually go with serialization, because the main focus here is that you actually introduce API calls. So you serialize your objects either through serializable tag or use our compact serialization feature. Now, I'll talk about these scenarios. What if we run an entity framework query and we get a single object back? What if we run a query and we get a collection of objects back? And then what if that collection has a related objects inside NCache already, right? In database, you have relationships, but when you bring data into the cache, you don't have the relationships. You have every object, available in its independent capacity. So I'm going to go over these scenarios one by one, and then we'll show you some code examples. So first of all, this is my application right here. I've done a connection to the cache, and this is an entity framework application. I've introduced my caching calls inside it. So this is the command which I've used to introduce initialization parameters. NCache.initialize cache takes a cache name. Here I'm specifying the name of the cache. So if I specify demo cache as the name, it will connect to the cache that we just created, and then it returns a cache handle, and then you can call cache.insert to introduce any key value pair that you need to add. This is just to highlight how it allows you to add data, and that's it. And similarly, you can just call cache.get and then return the same key back, and it would get you the same item back, and you can get it inside a string, and then you would get the same item back. So this is how easy it is to get started with it, and this is exactly what I've done today, and we'll cover the single object scenario at the at first. So we have this load customer, which actually typically it loads data from the database. So think on the lines that you don't have this. For example, if we just get rid of this, and then we'll get rid of this. So this is what we have introduced so far, what I've just commented on. So typically what you would have is you would go to the entity framework query, you would run a link query on the customer, and result, ahead of time that this is a customer object, and you construct a customer object, and iterate through the result. In this case, only one result, and then you return the customer back, right? Now what we've done is we've introduced a caching call where we constructed the key of this customer, and I mentioned that this is very flexible. This is what you would use to fetch data back and forth from the cache. So you get the context, customer ID, and then inside the cache you construct a key, provide a runtime parameter, which is the actual customer ID, and then you first check whether that data exists in the cache or not. You don't need to call entity framework upfront. You call cache first, because that's your priority. You want to save your trips to the database as much as possible, right? So you call cache.get, or this way you can check whether that key exists in the cache already or not. If it exists, you return from here. You don't need to call the entity framework. And that's how you save your trips to the database. Once you have cache fully populated, you would not have to go to the database. But what if cache does not have that value as yet, because we have not added anything into the cache as yet? So in that case, this would return a null, and then you would go through regular entity framework call, which you already have in your application. And towards the end, once you've got the object inside your application, while you return it, you actually add it into the cache. And this is the command which would actually takes care of it. So you're adding one customer object into the cache, and you return it back as well. So next time, if you load this, you run this customer again, this command again, you would not execute the entity framework call again for this method, because you would find the customer inside NCache. A single object gets stored in the cache automatically. I hope this covers it. Please let me know if there are any questions.
Sorry, I was on mute. Yes, I do have a question. Is cache.insert operation sync or an async operation? Is there a separate API for async? Just wondering.
Yes, that's a very good question. Even with cache, a typical operation, the one that I'm using right here, this is sync, but we do have an async operation for the same, and we have separate APIs for both. So you could just use this customer object and then you could store it asynchronously as well. I think it takes some more parameters. It requires a key and then a value. So I think I need a key. And then there are some other values, right? So just to let you know that, yeah, these are two different APIs. Async does this asynchronously on the cache, and you don't get an acknowledgement if it's successful or not. Mostly it is, and then you can rely on callbacks. Sync gets you acknowledgement. Typical TCP/IP, um, you know, handshake protocol. I hope that answers your question. Next scenario, let me just go through this quickly. What about collections, right? So if you have a collection inside, and for example, you plan on loading the supplier products, right? So again, let me show you what I have added. So this is what I have included in this particular command. Actually, let me not do it. In this particular method, this is what you would typically do, right? You would have a query run on the entity framework, and you end up getting a collection of products, right? So there are two options that you can do here. One option is that you store entire collection of this as a single object, and the query right here from this point onwards, that could be the key of the cache. For example, I can just call cache dot insert right here, and this can become my cache key. I'm sorry, yeah, I need to do some formatting here for string. Let me just bring this right here. Okay. All right. Now I have this key right here, and then I can add the product list as a single item into the cache, and that's good enough. Whenever I run the query, I don't need to run the query again. I just need to call this. I just need to pass on this query to NCache. That's one option, but that's not very sophisticated because it's actually dealing with all the products as a collection. So you have a bigger object, and that's not very efficient when you need an individual product from that collection. You would end up fetching the entire collection back. So alternative to that is, first of all, you iterate through that collection of products and store individual products inside the cache, and then tag them. I'm using a construct called tag, and it's a supplier product tag. And then I have all the products tagged, but they're still stored individually in the cache. So inside NCache is still a logical collection based on the supplier ID tag, but they're individual, but based on the supplier ID, they're treated as one big collection. And inside Entity Framework, you can call get by any tag, provide the tag only, and it would fetch you the same product list back, and you don't have to go to the database anymore. So that's how you deal with collections. You break down individual objects from the collection, store them individually, but you store them with a tag. Whenever you need to fetch them at once, you can just call get by tag. And then when you need them individually, you provide the key, which is right here. You're constructing the key of the product. It's pretty straightforward in terms of caching API, but since we need to align it with Entity Framework, in Entity Framework, you're getting a collection, which is a combination of a join or from two different tables. So it's up to you whether you want to store it as an entire one collection. If you need it as a collection all the time, there's no harm storing it as a collection. But from a distributed caching standpoint, we recommend that you store them individually and then tag them, so that when you need to fetch them individually, one item from the collection, you can do so. And when you need all items from the collection, you can use the tag API as shown right here. And then third, databases have relationships, right? When you bring the data into the distributed cache, you have every object independently stored. So how to take care of that? So we'll just go to cache customer orders. Yeah. So in this case, we have a customer object based on the customer ID. We constructed orders. So a customer, we were going to show you the one-to-many part, where we have a single customer which could have many side of the thing. So we've already demonstrated single item. We've already demonstrated how to handle collections, and then we'll show you how to link a single object with a collection in a one-to-many manner. So with the help of this particular API, first of all, you'll check whether that customer exists in the cache, and you would return from this point if you have to. Now, if it doesn't, you would go to the entity framework, get it, and then store it. So rules are exactly the same. Now in this case, we also have a collection of orders that we need to store alongside the customer. So we would just not store the orders collection as part of the customer object. We'll store orders separately in the cache. We'll go ahead, get the collection of orders, construct a dependency object which takes customer as a key, and then we store the collection of order customer.orders as a single object, or objects within that collection as individual objects inside NCache. Now this customer has a dependency. Actually, these collection of orders, this entire collection has a dependency on the customer. If customer gets removed in the cache, orders would automatically be removed. And this is done with the help of key-based dependency of NCache. So I hope this helps as far as example goes. What we're doing is we're storing individual customer as a separate object. And then from the collection, you can decide whether you need to have the collection which is related to this single object as one object, or objects within the collection could be separate objects in the cache. And then you can link the customer with the objects in the collection of orders, or the entire collection order as a single object. You can link in a one-to-one or one-to-many relationship. If a customer gets through a change, all the orders, if it's a single collection or all the orders individually in the cache, those will be removed from the cache automatically. So this is exactly what we've demonstrated. So that should take care of our object caching use case. So this completes our object caching. This would require your objects to be serializable, but this gives you a lot more control, because you can control what calls go to the entity framework, what calls go to the database, and to the cache. You control both sources yourself. Second option for using entity framework caching with the help of NCache is a no code change option. That's a no code change provider that we've implemented, and I'll take you to our documentation for that.
Ron, while you're paused, I have a question that came up. So how are these dependencies stored in the cache? Talking in reference to customer and his or her orders, are they removed instantly, or is there some sort of a periodic cycle?
Okay, there is a periodic cycle, but these are made unavailable right away, right? So we do a cleanup task in the background, and there's a 15 seconds configurable cycle that's called clean interval. You set up from here. If you go to the cache, on the cluster settings, I think it's on the main tab, you set up the clean interval 15 seconds. So that's one when we actually remove the items which are expired, but we make them unavailable for your user access right away, right? So it's instantaneous as far as user experience is concerned. There's a thread which would take care of it, but behind the scenes, the cleanup task, actually removing that from the cache repository, that's something that we do with the help of clean interval, and that's based on the periodic cycle. There's another question. I think the least recommended value is 15 seconds. We don't recommend having less than that, because it would just do a cleanup more frequently. All right, so coming back to the provider, I think we have 5 more minutes for my portion, so I just want to get done with that. So this is how you would use the entity framework second level caching, or NCache as a second level cache for entity framework without any code changes. These are the documentation side of things. So you plug in, let's actually go through this. So you plug in NCache provider, and this is the integrations assembly right here. alachisoft.integrations.entity framework. And then for 6.0, you would actually add this provider right here, and then provide the invariant EF caching provider service, and then alachisoft.ncache integration entity framework assembly. That's the main caching provider implementation of it. And then inside your application, you would use an app setting, app ID, and that should correspond to the client side configuration file that we have right here. So if I go to C drive, program files, NCache, we have this EF caching.ncconf, and we have, let me just open it in Notepad so that we can actually see through this. Right. And you have this EF caching demo app config mapped. Provide the name of the cache that you want to use so that all the NCache settings are centralized, and then you specify the queries that you want to cache. There are 2 modes. There is an analysis mode that you run and generate queries from Entity Framework without NCache, and then you pick those queries, put in this file, and then use the second level cache. NCache would cache these on ADO.NET layer automatically, and only these queries are going to be retrieved from cache. So each time you run this query, you would get this from the cache. And you can specify the expiration and database dependency on these queries. So if time gets elapsed, the data gets removed, or database changes, the data gets removed again. So that's a limited use case, but this is for those customers who actually want to use NCache for entity framework caching, but they don't have a liberty of uh, changing anything inside their application code. If the code cannot be changed for serialization or for introducing APIs, only then we would recommend that you use this. Otherwise, use the object caching API support, because that's something which is very flexible in usage and gives you full control on how you would like to interact with your application inside your application for the database as well as for the cache. And we've given you some examples to go about it. I hope this helps. There are some additional features. Alongside entity framework caching, you can encrypt data if that's a requirement. You can compress your data automatically. Security can be turned on the cache. You can get email alerts. So there's a lot that we can provide on top of caching support with the entity framework. So NCache is a pretty elaborate product when it comes to features, the object caching side of things, and the management and monitoring side of things. All right, so this brings us towards the end. I'll hand it over to you, Adam, and we can take it from there.
All right. Well, thank you, Ron, and thank you everybody for joining. This little slide, just, we've been around for a while. We're actually the first and the oldest .NET caching solution built in .NET for .NET applications. We have hundreds of customers around the world. The next slide actually shows a few of them. And then, so what's next? If any of you have any additional questions, want to have a one-on-one session where we actually demo the product, let us know. You can contact our sales department from our website, shoot us an email or a phone call. If you want to have a tech talk, let us know to go over some questions. Or if you actually want to get your hands on the product and demo it for yourself, it's available on our website. You can download it. It's a fully working licenses for our for our enterprise tool. So sorry about the phone ring. But yeah, if you need anything, don't hesitate. Let us know, and we'll sorry about that. We'll get back to you as soon as possible. But yeah, once again, appreciate everybody's time. Have a great day, and hope to chat with you all again soon.
Thank you, guys. Take care. Bye-bye.